Yesterday we said slope measures two things. What two things does slope measure?
How steep the line is and which direction the line goes.
Okay, good. So it measures two things, how steep the line is and which direction the line goes. As Tatiana just pointed out, all of these staircases are going in the same direction, in the positive direction if we're talking about slope, so up and to the right. So I don't really want to talk about the direction right now, but I want to talk about the steepness. How could I take what I know about these staircases here and determine which of the staircases is the steepest? I think looking at them, it's pretty easy to tell which one's the steepest. Maybe. Maybe not. However, how could I quantify that? How could I use some numbers to say, I know this staircase is steeper than the rest of them? Tiffany, what do you think?
Using the grid, could you count like how many boxes you want to go up and how many boxes you want to go deep inside and go up and down with the stairs?
Okay, so do you want to do like the whole staircase or just one step?
One step.
Okay. And actually, Tiffany, there wasn't a wrong answer there. Either one would have been acceptable. So let's look at each staircase, and we'll just take one step at a time. So in this staircase here, how far do we go up, Tiffany?
One.
We go up one, and we go over how far?
One.
We go over one. Okay, in this staircase here, how far do we go up and over?
One.
We go up how far?
Two.
We go up 2 for every one we go over. How about this one? Up 2 and right 2. Okay, how about this one? Up 1 and right 2. Okay, how about this one? Up 3 and right 2. Okay, and how about this one? Up 2 and right 3. Okay, I think that's all of them, right? Now, looking at these, I might immediately think, well, this one's the steepest because it's going up the most. Do you guys agree with that?
No.
Why not? I think it makes sense.
Compared to the other number, it isn't that much.
What do you mean by that?
Like, if you take, I don't know, like if you take the 2 and the 1, and you,
Okay.
and you times by 2, that would be 4 and 2, so that's not.
Okay, Miles just made a good point. Let's look at this staircase right here. And so that we can compare them a little bit easier, he said multiply it by 2. So that would be the same thing as effectively making every 2 steps into 1. So go up 4 and right 2. Go up 4 and right 2. Do you guys agree with that? So this staircase here, and I'm going to make it a little bit darker so you can see, this staircase here is the same steepness as the one we started with, but now all of a sudden we're not going up 2 and right 1, but we're going up 4 and right 2. Now, why does that make it easier to compare to this staircase? Miles?
Because you're comparing, like the rise, which is the steepness, to the run. Like, they have the same run, but what you're trying to compare is the rise, not the...
Okay, good. Miles has the idea here now. So for any horizontal change of 2, so here we're going forward 2. If you think about this as you're making progress or you're going forward as much as you can, for every forward progress of 2, you have to go up 4 stairs. Down here, for every forward progress of 2, you have to go up 3 steps or 3 blocks or 3 whatever, 3 units. So for all things being equal as far as how far you're going, you have to go higher on this staircase than you have to on this staircase. If I wanted to be able to compare all of these staircases at the same time, then I probably need to make that run the same for all of them, right? Most of them we could convert to 2 and 2, or a run of 2 pretty easily, except maybe this one right here. We couldn't convert that to 2 very easily. This one. So we would probably have to convert everything to maybe a run of 6 so we could compare all of them. Or another way to think about it is let's make the run 1 on all of them. if we make the run 1 on all of them, this one right here would have been okay to start with. This one right here, we could do what?
Divide.
Divide by 2, and we would go up 1 for every one we go over. So that one's okay. What could I do here on this one? Same thing, right? I would just get a what? For every one that I go over, how far do I go up? I'll draw the picture in here. Austin's got it, although he's saying it as a decimal. I would probably say it as a fraction. But yeah, it's 2/3. So if you go up 2/3 and then over 1, up 2/3 over 1, up 2/3 and over 1, you get the same thing. You get the same slope. So you go up 2/3 for every one you go over. And you get that just by dividing by 3, right? So now we can compare that to all the other ones. We can divide this one here by 2, and we get up 3/2 for every one we go over. Over here, we go up, how far? A half for every one we go over. This one here is already done for us. So if we change all of the runs to the same thing, now it's really easy to say, okay, this one's the steepest, this one's the next steepest, this one's the shallowest or the least steep. Which one would be the least steep? Is that the correct way to say it? Which one would it be? The 1/2 one, right? Because 1/2 is the smallest of all those numbers. 1/2 is smaller than 2/3, right? So this staircase right here, and I keep doing this the wrong way. This staircase right here would be we would say maybe it's the easiest to climb because it's got the least slope, or the lowest slope. Because we only go up a half a block for every one we go over. Compared to this one here where we go up 2 for every one we go over. Okay? So what we're doing here is we're kind of informally looking at the idea of slope as a steepness. If we can compare how far we go up to how far we go over, that's going to tell us how steep something is. All right, so if we want to do that on a coordinate plane, then we need to... Did we do this example yesterday? Okay, I didn't think so. So if we want to do this on a coordinate plane, what we can do is we can plot the points and do exactly what we did in the last example, or with the stairs. We can compare how high we're going to how far we're going. We can also incorporate a positive and a negative slope in there to determine if we're going up or if we're going down as we go left to right. So let's go ahead and plot these points here. Alright, so we've got our line drawn here through our points. Using this idea of rise over run, how can I find the slope? How can I find this number here that's going to tell us exactly how steep the line is? Let's build some stairs, or a stair at least. Which point should I start at? Should I start at 1, 0, or 3, 4?
1, 0.
Okay. Why should we start at 1, 0? Okay. I heard a lot of reasons, and none of them were really why we want to start at 1, 0. The reason we want to start at 1, 0 is because we always want the run to be positive if we can. The run is going which way?
That way. Right.
Right or left? A positive run is going to the right, a negative run is going to the left. So if we want the run to be positive, we want to go from left to right. Okay? Rise is going which way? Up or down. This gets kind of confusing, but a positive rise is exactly what you'd expect. It's going up, but rise can be negative. Rise can be going down if it is negative. So rise is either up or down, and that's going to tell us if it's positive or negative. So we're going to start at this point here, because we want to go from left to right. It's because it's to the left of the other point. Now, if we want to do rise over run, we want to go up first or down. Which way should we go, up or down?
Up.
Up. How far do I have to go up before I get to the other point?
4.
I go up 4. How do you know it's 4?
Because the thing's there.
Because of the 4 there?
Yes.
Yeah, because we're going from 0 to 4. That's an easy measurement, right? If you're going from 0 to anything, it's just that number. Since we went up 4, is that a positive 4 or a negative 4? It's a positive, okay. Once we go up 4, let's complete our step by going to the right. How far?
2.
Okay, now how do we know that's a 2? Because I see a 3 right here. Because we're going from 1 to 3, exactly. Now we went to the right 2, so is that a positive 2 or a negative 2? It's a positive 2. Now, when we were comparing the steps, we always made a 1 on the bottom. We don't necessarily always need a 1 on the bottom here, but we do want to simplify it. So what does 4 over 2 simplify to? That's just 2. Now there are 2 acceptable answers here. 2 is actually the second one I'm going to write. Normally we wouldn't want to write 2 over 1 in math. 2 over 1 is not a simple answer. It's a fraction when it doesn't need to be a fraction. However, slope is a ratio. The slope is the ratio of the change in y over the change in x, or the rise over run. Since it's a ratio, it's acceptable to write it as a ratio even when it's a whole number. So 2 over 1 would be acceptable, or 2 would be acceptable. Either one of those would be okay. Any questions about that? Alright, so then let's do another example. I like this example. What's going on here? Does anybody know where the point x1, y1 is? No, me neither. Why not? Yeah, they're variables, right? What that means is the point x1, y1 can be anywhere, right? So I'm going to just put these points anywhere in the coordinate plane. It really doesn't matter where. But if I'm going to graph it, let's go ahead and put the x's and the y's on the So I'm putting the x's and the y's on the axes here. It really doesn't matter where you put them. But now that I've got those there, now I know where the points are. So x1, y1 would be right here, where x1 is on the x-axis and y1 is on the y-axis. And x2, y2 would be right there. Now, the way I have it drawn, is the slope here going to be positive or negative? It's positive. Why is it a positive slope? Yeah, as you go left to right, it goes up. So as I have it drawn, it's a positive slope, but we don't necessarily know it's positive. As far as this problem goes, that doesn't actually matter, because the way we're going to do it, it's going to account for that. Okay, so the slope is rise over run, right? Rise is how much we go up. So which point should we start at here? Should I start at point 1 or point 2? Yeah, I'm going to start here for 2 reasons. First of all, I don't actually know that this is to the left of this one. It could be to the right because these are variables and x1 could very well be bigger than x2. But I'm going to start here because I have it drawn to the left and also because I would normally start at point 1 and go to point 2. So we'll start here, start at x1. And in the picture that I drew, this wouldn't necessarily be the case depending on what the values of the variables are, but in this picture, which way do I need to go? I need to go up. Anybody know how far up that is? Okay, we are going up to y2, but this distance right here is what?
y2 minus y1.
Good, William. It's y2 minus y1. So we talked about this 2 days ago. That should be a 1. We talked about this 2 days ago when we're finding distance along an axis. we can just subtract the values on that axis. All right, and now once we've gone up to y2, now we're going to go which way? We're going to go to the right. And how far to the right do we go? We're going from x1 to x2. So how far is that? x2 minus x1. And guess what this is right here? That is the slope formula. Not the distance formula, but the slope formula. So we get the slope formula just by doing rise over run with two arbitrary points. So we can think of the slope formula as rise over run, or we can think of it as y2 minus y1 over x2 minus x1. The difference in the y's, that's telling us how far we go up, over the difference in the x's. That's how far we go over. I want you to notice that in both of these formulas, the rise is the distance along the y-axis, and the run, or the bottom number, is the distance along the x-axis. I'll give you a minute here to plot your points. Go ahead and plot the points, draw the line through them, and then we're actually going to do this two different ways. I want you to do it both ways in your notes. We're going to do it on the graph using the rise over run idea, and then we're also going to do it using the slope formula. Which way you guys want to do it first? On the graph using rise over run or using the formula?
Rise over run.
Rise over run, okay. Which point should we start at first? -2, 4 or 1, -2? Okay, why would we start at 1, -2? Remember, what do we want to be positive, the rise or the run? We actually want the run to be positive. When you have a fraction, if a fraction is going to be negative, where do you want the negative sign to be?
On top.
On top. So if one of those two things is going to be negative, we want it to be the rise. Which means that for the run, we have to go in which direction? We have to go left to right. So since we're going from left to right, we need to start at this point, at -2, 4. So we're going to start here at -2, 4. And which way are we going to go? Yeah. So our first one, rise is up or down. So we'll go down from 4 down to -2. How far down is that? So we're going down 6. Is that a positive 6 or a -6? It's going to be negative since we're going down. And then we're going to go from -2 to +1 on the x-axis. That's going to be a run of 3. And there's two acceptable answers here now. What are they? -2 over 1 or just -2. Either one of these is okay. Any questions about how we got that from the graph? Okay, how about using the formula? Anybody think they can plug those numbers into the formula for me? y2 minus y1 over x2 minus x1. Go ahead, Tiffany.
-2 minus 4 over 1 minus -2.
Okay, and Tiffany, what is -2 minus 4?
-6.
And what is 1 minus -2? And what did we end up with?
-2. 4. -2.
Yeah, same thing we had in the last one, right? This is another example of a problem type that it may be easier to draw the picture and do the rise over run. It may be easier to do the slope formula. You do need to be comfortable using the slope formula because not only are you going to need it this year, but you're going to need to be comfortable using it in the future, in next year's algebra class and then beyond, depending on how far you go in your math career. Okay, moving on. Let's do another example. Yes?
If you want to work with computers, do you have to take a lot of math?
Did you just roll your eyes?
Yeah.
All right, same thing here. I want you to plot the points, and we're going to do this one actually 3 different ways. So if we want to find the slope of this line using the rise over run formula here, which point should we start at? The one on the left, which is this one here, the negative 4, 5. So if we start there, what is our rise going to be? Going from negative 4, 5 to 2, 5. Yeah, it's 0. We don't have to go up or down at all to get even with it. So our rise is going to be 0. What's our run going to be? Going from negative 4 to 2. It would be positive 6. What's 0 divided by 6? 0. So the slope of this line is 0. Now, if you didn't notice it before, you may be looking at this and saying, oh, yeah, I should have known that. The slope is 0. We'll come back to that. How about the slope formula? y2 minus y1 over x2 minus x1. Who can plug numbers in for me? Tatiana?
5 minus y over 2 minus negative
2 minus negative 4, is that what you said? Okay, 5 minus 5 is? And 2 minus negative 4 is? And we get the same thing we got on the last one, right? Now, from the very beginning, who can tell me how we would have known the slope was 0 without doing any work? All lines are straight. Quit saying they're straight lines. Kayla? It's a horizontal line. And what do we know about a horizontal line? Don't say there's no slope. There is a slope. The slope is? The slope is 0. Okay? What do you guys remember about the skier on the horizontal slope yesterday? He didn't move. He didn't go anywhere. Okay, so we can think about that as a 0 slope. So just looking at this and seeing that it's a horizontal line, we know that the slope is going to be 0. Likewise, in this example here, we're going to have a similar type situation. It's going to be a little bit different, but similar. We'll go through and we'll look at it from all three perspectives, and we'll talk about why we get what we do. Be careful with your terminology on a line like this. Don't say this is an undefined line, because that's not true. The line's right there. Don't say that it's an infinite line. Unless you're talking about the length of the line, then it's an infinitely long line. But also, the slope is infinite or undefined. So when you're using the term slope, or when you're using the term undefined, you're not talking about the line, you're talking about the slope of the line. Be careful about that. So we know we're going to get an undefined slope here. It's a vertical line. We know that. So let's look at why we get an undefined slope from both of those perspectives, from the rise over run perspective and from the slope formula perspective. Starting with rise over run. Do we know which point we should start at here? No. It really doesn't matter in this case, because neither of these points is to the left of the other. So I'm going to start at the bottom one. And starting there, what is my rise? Yep, I go up 4. And what is my run? 0. Once I go up 4, I'm at the other point, so my run is 0. Now, type in your calculator, 4 divided by 0, what do you get? You don't even have a calculator. How do you know?
Because I did it before.
Yeah, you can't divide by 0, can you? Does anybody know why you can't divide by 0?
Because it's 0, it has no
Think about what division means. Let's say you're going to do the problem 12 divided by 6. So that would be an example. Let's say you made 12 cookies. You have 6 friends, and you're going to give each of them an equal number of cookies. You do 12 divided by 6 to figure out how many each of them gets, right? Okay. So what if you have 12 cookies and you have 0 friends, and you want to give each of your friends an equal amount of cookies? How many cookies does each of your friends get?
You don't have any friends.
It's a nonsensical problem. It doesn't make sense, does it? You're just going to have to eat all the cookies yourself, but you didn't give any away. It doesn't make sense. Yeah, you're right. It's not that bad. Moral of the story, don't have friends so you can eat all your cookies. No. That wasn't the moral. You can't divide by 0. That was the moral. Um, so
I use it though, I don't like the cookie.
this tells me two things. First of all, if we take a big number, or really any number, and divide it by a really small number, what do we get?
Number,
If you divide by a small number, what do you get?
small, big number.
Somebody do it for me. Tiffany, type in 4 divided by 0.01. What kind of number do you get?
A big one.
A big one, right? So if you divide by a small number, you get a big number. Well, 0 is so small that the number we're getting is, starts with an I, infinite. Okay, so we get an undefined slope here, or we could call this infinite slope. We'll go ahead and call it undefined now, since that's what you've probably done all your life, and I don't want to confuse you too much.
I like a challenge.
Oh, so you do want me to?
Nah, we're good.
No. I think
All right, let's look at it again from the perspective of the slope formula. Y2 minus y1 over x2 minus x1. What's y2?
4,
What's y1?
0,
x2?
1, 1.
Okay, so we get 4 over 0, which again is where we were at over here, and we get an undefined slope or an infinite slope. Does that make sense? Okay, we have, what do we have? 2 more examples. I misnumbered the next example. It says 40.10. It should say 40.20. So be sure you change that in case I ask for that one on a binder check. You know which one I'm doing here. So in these two examples, these next two examples, we're going to do the same thing. I'm going to give you 2 points. We're going to find the midpoint, the distance between the points, and the slope of the line containing the points. I'm going to do one of the problems one way, completely on the graph, and I'm going to do the other problem the other way, completely using the formulas. Let's start this one, just for simplicity's sake. Let's do this one using only the formulas. So I'm actually not going to draw the picture. I would like you to draw the picture, and I'll actually draw the picture also just to show you what something's going to look like here at the end. But we're going to do this completely with the formulas first, and then we're going to, well, and then we'll look at what it looks like. All right, so we're just going to plug these numbers into those formulas. So 2 is going to be our x1, negative 3 is going to be our y1, and negative 4 is going to be our x2, and 0 is going to be our y2. So who can help me with the midpoint formula? The x-coordinate of the midpoint. What'd you say?
2 plus negative 4.
Okay, what's 2 plus negative 4? Divided by 2? Okay, so we get negative 1 for the x-coordinate. The y-coordinate of the midpoint. Kayla, you want to do that one too? It's negative 3 plus 0. Divided by 2. How about negative 3 halves? I like the fractions better. As far as plotting points, it actually would probably be more useful to have it as negative 1.5. So let's go ahead and put it that way, negative 1.5. It really doesn't matter as long as you know where negative 3 halves is relative to the whole numbers. So what's our midpoint going to be? Okay, so we got 1 done. We got the midpoint. Now let's do the distance. Who can help me plug numbers into the distance formula? I'll even put the skeleton up here for you. Austin?
Negative 4 minus 2.
Oop.
And then 0 minus negative 3.
Alright, and what is negative 4 minus 2?
Negative 6.
We got negative 6 squared there, and 0 minus negative 3.
Positive 3.
Okay, good, so we get 3 squared there. Negative 6 squared is,
36.
and 3 squared is,
9.
So we have the square root of 36 plus 9, which is the square root of,
45.
anybody know off the top of your head what that is?
3 to the square root of 5. Yeah.
Yep, that's it. Okay, so there's the distance between the points. And the last thing is going to be the slope. So we're going to have the difference in y's on top and the difference in x's in the bottom. So who can tell me what to write on top? I hear somebody mumbling. Who is it? 0 minus negative 3. And on the bottom? Negative 4 minus 2. What's 0 minus negative 3? 3. We actually figured that out already right here, didn't we? And for negative 4 minus 2, we figured out there was negative 6. And is that my final answer? No. I need to simplify it. First of all, if we have a negative on a fraction, we don't want it to be in the denominator. Where do we want it? The numerator is best. You could put it out front. As far as slopes go, we want it on one of the numbers, though. So I'm going to put it in the numerator. And what can I do with the 3 and the 6? Simplify it to 1/2. So our slope here is going to be negative 1 over 2. Which means that on our coordinate plane, on our grid, we're going to go down 1 square and go right 2. So you can kind of picture what that's going to look like. For every 1 we go down, we're going to go right 2. And we're going to get a line with a slope about like that. Okay? So I have a pretty good idea of what this line is going to look like without even looking at the line. Because I know where the midpoint is. I know what the distance between the endpoints is. I know what the slope is. So we know a lot of information about it without even looking at it. Now, who can tell me what we would do to graph something like this? Negative 1, comma, negative 1.5. In this example, I would like to put everything on the coordinate plane and get all the information that we need from the picture instead of from the formulas. So let's go ahead and graph it and then we'll talk about it. Now, when we're finding the midpoint here, it's actually kind of difficult to escape the formula. We really have to use the formula because when we're finding the number halfway between two numbers, for example, when we're trying to find the number halfway between negative 1 and 2 on the x-axis, what do we have to do? How do we find the number halfway between two numbers? We take the what? We take the average. So we're really doing the formula here for this part by taking the average of the two numbers on the x-axis. So for the midpoint, the x-coordinate of the midpoint is going to be the average of what two numbers? What did you say, Maya? Good. So we're going to find the average of negative 1 and 2 by adding them together and dividing by 2. What is negative 1 plus 2? 1. So we get 1/2 for the x-coordinate. And the y-coordinate of the midpoint, we're going to average which two numbers? Negative 2 and 4. What's negative 2 plus 4? 2. And divided by 2 is 1. So we get a midpoint then of what? 1/2 comma 1. And if we graph that on the coordinate plane here, it looks like it's going to be right about there. I'm not going to take the time to mark that on the axes, but does that look about right? About where 1/2 comma 1 should be? Okay. How about the distance? Let's find the distance here between the 2 points. What should I do? What should I draw in this picture here so that it'll help us find the distance? What kind of triangle? A right triangle. Oop. It doesn't really matter if we draw it above or below the line. I've talked about that already. So I'm going to draw this triangle over here. I think I am. There we go. So there's our right triangle. We're drawing a horizontal and a vertical line here. And how do I find the lengths of those legs in that triangle? let's say this leg right here. How do we find that length? Yeah, Dante's right. So this length right here is the same as going from -1 to 2 on the x-axis, and that's going to be how far? 3. And how about the length here, the vertical length? That's going from where to where on the y-axis? -2 to 4, which is how far? Okay, so now we can just set up the Pythagorean theorem to find this. So let me get some of this work out of our way here. Who can set up the Pythagorean theorem for me? To find this distance right here. Jake?
3 squared plus.
Sorry. 3 squared plus 6 squared. Leg squared plus leg squared equals d squared. Okay, so we have 3 squared plus 6 squared equals d squared. And what's 3 squared? Yeah, we actually just did this, didn't we? Somebody just said that. We have 9 and 36 here, so we get the square root of 45, and so d is going to be 3 square root of 5. That's nice because we can save a little bit of work. Okay, we have one more thing we need to do, and I've actually done most of the work for the slope already, and we'll see why here. Which point should I start at? -1, -2, or 2, 4? -1, -2. We're going to start here. I'll fill that in so we can see it. And we're going to go up to 2, 4. So we're going to rise first. How far do we go up? 6. We already figured that out, didn't we? Okay, so we're going to rise 6 and we're going to run 3 because we're going to run here. And 6 over 3 is 2 over 1 or 2. That's not a 2. So either one of those answers, again, would be acceptable. 2 over 1 or 2.